Hello, in this video we would understand what is a dependency graph node and how we can build our own dependency graph node or a custom node using OpenMaya. So the first thing we would like to understand is what exactly is dependency graph node. Any node of a dependency graph that has an ability to perform any computation. Any node of dependency graph that has an ability to perform computation is a dependency graph node. And what it is composed of. Dependency graph is composed of four things. One is an attribute, second is a data block. At this point we know what are the attributes, because in the previous video we saw what are attributes and what are plugs. Any input or output of a node is an attribute, and there is a way to access those attributes using a specialized handle which is called as plug. In the same way, we would have specialized handles to access the data blocks. So this is an attribute, and this is data block, and the handle to access an attribute is called as plug, and handle to access data block is called as data handle. What exactly is data block? Data block holds all the data for the node, so whatever input and output is, data block is going to hold that. You can consider data block as a hard drive for a node, which stores all the data. So data block is a kind of storage. So now we understand what is attribute, what is plug, what is a data block, and what are data handles. And that's what a DG node is composed of. So now we understand what is dependency graph node. And now we would understand how we can build our own dependency graph node, or they're also called as custom nodes. Building dependency graph node is a lot similar to build the Maya command. So we would take a look at the code which we wrote previously when we understood how to write the Maya command. So here we have a class, then we have a creator function, then we have initialize plugin and uninitialize plugin. We understand at this point why we are using initialize plugin, uninitialize plugin, command creator, and this class. So now we would start designing the structure of our dependency graph, and then we would code it in Maya. So to design a dependency graph node, we would need a creator function, and then I'm skipping one step, and then we need initialize plugin. Fourth, we need uninitialize plugin. Second thing is we need an extra function which we did not use for creating the Maya commands, and this is initialize function. You can also call it as initialize node function, but I'm calling it as initialize function. So what this function does, initialize function initializes all the attributes of a node. With that, we would need a class, and similar to what we had in command plugin, we had a constructor and we had a doIt function. We will have a constructor. Secondly, in the Maya command, we had doIt function, which in this case will be replaced by compute function. And we would have to keep the name of the compute function as compute. We can't give any other name to this function because Maya looks for this name in the class. So that's all we need to create a dependency graph node. We would understand initialize function in more detail now, and what it does, how it initializes attribute, and how we can add the attribute. So we know that initialize function initializes all the attributes. So what we need to initialize all the attributes is, first, we are going to use a function set. And this function set would be for the attributes. If you will look up for MFN attribute inside Maya 2013 API documentation, you would find there are different type of function set attributes. And for our case, we are going to use MFN numeric attribute. So this is a function set of numeric attributes. And this function set provides us an ability to create different type of attributes. So first, we need a function set for numeric attributes. Secondly, we are going to create attributes, and we will be using function set to create numeric attribute. Third thing is we would attach the newly created attribute to the node. And the fourth step is to design a circuitry inside the node. So for example, we have two inputs that can be accessed by their handles. They are mplugs, and there is an output node. So in this fourth step, we would design a circuitry that if there is a change in this attribute, this should reflect the change in this output. So this is input, input, and output. So in the fourth step, we would design circuitry. So at this point, we understand the basics of designing a dependency graph node. And now we would go in Maya and start creating the dependency graph node and writing some code. So let's go to Maya and start writing. To write something useful in Maya, we would write a wheel node as a dependency graph plugin. And what a wheel node will do is it would calculate the rotation for the wheel based on the translation. So this calculation requires two things. One is the radius of circle or the wheel, and plus the translation. And based on that, it would start rotating the wheel. And if I would show you the hypershade, so this is the custom node which we are going to create, and it takes two inputs. The inputs are radius and translation, and the output is rotation of the wheel. We will take a look at the formula for that. So the rotation here is equals to translation divided by 2 pi r, which is the formula for the circumference, into negative 360. So the variables are translation and the radius. 2 pi and 360 are the constants, so we don't need them as input. So the way we are going to design our node is we would take a node, there would be two inputs, translation and radius, and there would be output which would be rotation. So this is how we are going to design our wheel node. So this is our basic structure. So let's get back to Maya and start writing the code. here we are in our script editor, and we would do the basic steps which we did in while creating the plugin command. So first is import sys import maya dot open maya as open maya, import maya dot open maya mpx as open maya mpx. Let's execute these. Then we would create two variables, and this would be the name of the node. I will call it as wheel node, and node ID. So what is node ID? Node ID is a unique ID which defines a particular node. So everything or every node that exists inside Maya has a unique ID, whether it is supplied by Maya itself or it is a custom or user created node. For example, light node has a different ID, transform node has a different ID, shape node has a different ID. In the similar way, when you are going to create your custom node, you would have to define an ID to it. You just for the testing purposes, you can define a hexadecimal number to it. I'm going to define an hexadecimal number. But when you are finalizing your custom node and you want to release it, you would have to request this unique ID from Autodesk. You can request it from Autodesk Developer Network, ADN, and they would provide you the range of the IDs, and you can use that range for different custom nodes. Alright, so we have defined our ID, and so mtype ID is a function we are going to use to define the IDs. So we define our IDs. Now we would write a class, and I would name my class as wheel node. And in command plugin, we inherited a class open maya mpx command. In this, we are going to inherit a class open maya mpx node. This is the class we need to create a custom or dependency graph node. Alright, then we know that we would have to define or write a constructor. So the next thing we would do here is we would also call the constructor of our inherited class or the base class. So here is our constructor. The next thing is we discussed that we would define a function called as compute. I would leave this function for now. I'm not going to write any code for it for now, but when we would come to this function, we would write the code for it. So this is all we need to define inside the class. And then we discussed that we would need 4 different things, which is creator function, initialize, uninitialize plugin, and initialize plugin. So first we would create these 2 functions, creator function and initialize function. And remember, they are going to be outside the class. In command plugin, we created this creator function. We called it command creator, which is more understandable or more readable. And we created a plugin or pointer using this. So I'm going to copy this and paste it here. Instead of plugin command instance, I'm going to use wheel node so that it can return a pointer to the instance of a wheel node. The first step is done. The second step is to define node initializer. And in the node initializer, we saw we need a MFN function set. Then we are going to create the attribute, and then we are going to attach the attribute to the node, and then we are going to design the circuitry. So first thing is to create a function set. I would first create function set. So this is my step 1, creating a function set for numeric attributes. Okay. Second step is to create the attributes. So creating the attributes further has some sub steps which we would understand in our chart, and then we would understand what we would write the code for it. So the initial most thing is to create these things. Then we subdivided initialize function into these 4 parts, right? And in this step, we are going to subdivide create attribute into further step. So in this step, we would understand how to create plus set properties of the attributes. Create attributes and set properties. So in this first step, we will create the attribute using function set. So we will use MFN function sets method to create attribute. This is what we are going to use. And what this will return to us is it would return us an M object handle. This is what it's going to return us, M object. So far we have heard that M plugs are the way to access the attributes. But yes, while we create the function using the create function of function set, it gives us M object. Now we would need something to store this return M object. Second thing is we would set the properties, and most basic properties are: is the attribute readable, and what is readable attribute? Readable properties or readable attributes are those attributes that can be used as source in the dependency graph node. And then writable. Writable attributes are those attributes that can be used as destination in the dependency graph node. Only those attributes can be set using set command that are writable. So we want to make writable only inputs. Whatever the input attribute is, we want to make that writable. We don't want to make output attributes as writable. So output attributes would just be readable. Third thing is, are they storable or not? So this property makes the attribute value to be stored in the scene when we store the file. And we also don't want to make our output nodes storable. We just want to make our input nodes storable. Fourth thing is keyable. Can it be keyed or not? Stored with file can be keyed or not. So for the output variable, we are not going to set these properties. There are certain more properties which we are not going to discuss at this point, because for creating this node we just only require these properties. So our input node can be readable, writable, storable, keyable, and our output node would be just readable. Now we would use mfn dot create function, and the first argument of this function is the long name of the attribute, and the second argument is the short name. So for the long name I'm using translate, and for the short name I'm using t. And then we would define what kind of attribute it is. What is the data type of this attribute? And the data type of this attribute can be defined using numeric data function set. And in this case we want to use float, and then we can define the default value of that attribute. Now we saw in the slide or the chart that this function is going to return us an M object, and we want to store that M object somewhere. And the best idea to store that M object is inside that class, so that whenever we instantiate that class, we have those handles to receive some information. So in the class I'm going to define 3 handles, because we have 3 attributes in this node. So I'm calling the input attributes as in, and I will call in radius is a type of M object, and second attribute is in translate, which is also M object, and the third is output attribute, which is rotate. So we have defined 3 different M objects, and when we would accept the return of this function, we are going to use the attribute or M handle of wheel node class. So wheel node dot in radius is equals to the handle. Then we are setting the properties. So we have accepted this handle. Now we would go to step 2, setting the properties. And the way we would set the properties is m fn attr dot set readable. We are not using wheel node dot in radius dot set readable. We are using mfn attribute or mfn attr dot set readable. So because this is a input attribute, we are going to set it as dot set writable, and we would have to pass true and false or 0 or 1. So set readable 1 equals to set readable true, set writable true. mfnattr, we want to make it storable as well, so that it can be stored with the file. And the last thing is we want to make it as set keyable. So here we are done with our one of the attribute. Second time is wheel node dot in translate. We are going to use same attribute function set, and this would return us a new handle which will go inside, or which would be accepted by in translate, right? So I changed the value. I accidentally typed it as translate, which should be radius. So I have corrected now. So the full name or the long name should be radius, short name should be r. Here we would use translate comma t. And what would be the data type for it? Kfloat type data, and the default value we want is 0, 0. Now because it has returned a new handle, it has also reset the values, so we would have to set the properties again. And because this is an input attribute, we are going to set it as readable, writable, storable, and keyable. Now we are going to set our output node, which is out rotate mfnattr dot create. The long name should be rotate, rotate, comma short name is rot. The data type would be kfloat. Okay, so one thing to understand, because the output node would be calculated by our formula, we cannot set the default value of it, because it would come by a calculation. So in this case we would just define what kind of numeric data it would be, or what kind of data type it would be, and there is no default value. So for writable node, because it has reset all those properties, so we would have to set them again. So we want to make it readable, yes. We don't want to make it writable, we don't want to make it storable, and we don't want to make it keyable. So here we have set all those properties as 0 or false. Now the second step is complete. We have completed this section. We have come back to this section, and we have already used our function set, we have already created our attributes. Now we want to attach those attributes to the node. So how we can attach to the attributes to the node is, we are going to use our wheel node class dot a function called as add attributes. And which attribute do we want to attach? Which is accepted by node dot in radius plus we also want to add in translate, we also want to add out rotate. So this is the third step, attaching the attributes to the node. Alright, now we are back to define the fourth step, which is designing the circuitry. How we are going to design the circuitry? So we would let Maya know that if any of the input attribute is changed, there would be some change in the output attribute, because our output, which is rotate, is based on translate and rotate. So either of these values will change, it would reflect a change on our output. So designing a circuitry means defining what input would affect which output. So in this case we just have one output. There can be a node in which we have multiple outputs. So if, for example, if we have a node which has 1, 2, 3 inputs or 2 outputs, and combination of input 1 and input 2 changes output 1, and combination of input 3 and input 2 changes output 2. So if input 1 changes, there would not be any change reflected on output 2. So we don't want to do or perform any calculation for output 2. We just want to perform calculation for output 1. So that's why we design this inside circuitry and let Maya know, okay, if I am modifying input 1, there would be change in output 1. But in case of input 2, there would be change in output 1 and 2 as well. So in those cases, or in such kind of cases, the circuitry is a lot useful. So we would use a function Now we are performing all those functions on this wheel node class because we are attaching the attribute to the node, we are designing the circuitry of the node. Now we are going to use a function which is attribute effects. It would take 2 arguments, dot in radius, which is the source, and wheel node dot out rotate, destination of our circuitry. So if this is a line, I1 is the source, O1 is the destination. So which affects what? Second, we will let Maya know that if there is a change in wheel node in translate, change wheel node dot out rotate. And this circuitry is a lot useful for the dirty propagation of dependency graph. So we have completed our 4 steps, and we already have our creator function and initialize function. We wrote initialize plugin and uninitialize plugin in Maya command. So we are going to copy them from here and paste it here. And they are the separate functions. So we are making 2 changes here, or 3 changes. First, we are going to use register node function, which takes node name instead of command name our node creator function. I will just double check that's how I spelled it. Node creator. It takes two more things. Second is we define the node ID because each node has a unique ID. And the fourth is node initialize function, which we just wrote. I will just double check the spelling of that. It's node initializer. Alright, so we have made changes on register node, and instead of command name I will replace it with node name. So now we have the complete structure of our dependency graph node, and the only thing that is left is writing the compute function, where we would define our formula that we need, and rotate is equals to translate divided by bracket 2 into pi r, which is 3.14, into radius, and this whole thing will be multiplied by negative 360. So this is our formula. So we remember, or we just wrote, is that we designed our circuitry. When input 1 changes, output changes. So whenever there would be a change in input 1 attribute, or the radius attribute, or the translate attribute, Maya will call the compute function of this node, and it would send the plug of the output attribute, because here we told Maya that I1 reflects the changes in O1. So it would send you the plug of the output node. So the first thing is self, because it's a function of the class. Second thing, it would send you the plug. There is one more thing we discussed, data block, that we have not used so far anywhere in the code. So when it calls the compute function with the plug, it also sends you the data block with all the input values. So there is no value for the output, but it would send the data block, and it's a container of all the values. Here we got two extra things, plug and data block. Now we would check, because we want to perform the calculation if we receive the output plug or out rotate. So we would set a if condition that if plug is equals to wheel node dot out rotate, then do the following calculation. So it's this kind of structure is more useful for the complex nodes where we have multiple inputs and multiple outputs. So in this case, this structure would have been more important. So we would write if plug is equals to wheel node dot output rotate. Then do what? We would take the data block, and we know that the plugs or the handles to the data block are called as data handles. To receive the data from the data block, we would create data handles, and for each input, or for each input attribute, we would define a separate or its unique data handle. So data handle radius would receive or would be a pointer to data block which Maya sent us, and input value. So here we know we want to receive the input value because we designed the node and we know what kind of attribute is what. We know that wheel node dot in radius is an input node. So from this container, from this data block, we would extract the information of in radius, and with the use of handles we would point that information or block of information. And in the same way we would create a handle for translate, which would receive the value from data block dot input value wheel node dot in translate. And so this data handle radius is a pointer to data block. It's not a readable value. So we want this data handle to return us a value which we can read. And we know that these attributes are float attributes because we defined it as kfloat. So to receive the float value from this data handle, we would say data handle radius dot as float, and we will receive this information in radius val. In the same way, in translate val is equals to data handle translate as float. So we have two data handles and we have extracted the float value from it. Now we can start performing our calculation. We would use this formula now, which is out rotate is equals to in translate val divided by 2 pi r, and r is in radius val, and we will multiply it with negative 360, and we would also explicitly cast that as float so that in case we receive any 0 in denominator, it would not give us infinite, or it doesn't cause any problem in our node. So we have written our formula here. Now we would create a data handle for our output rotate, which would also come from data block dot output value, because we know that it's an output value, wheel node dot out rotate, and these are the names of the handles which we created. Okay, that's why it's important to declare them inside the class. So now we have the data handle for rotate as well. In the same way, we would set it as float because data handle pointer is not a readable value, right? So we would use a function called as data handle rotate dot set float. So when we read it, we use as float, and when we set it, we use set float. And what we want to set as float, this value which we calculated by formula. Okay, so we have our data block, data handles, readable values, calculated output, data handle of the output, and value which is set to data handle. We would use one more command here which is very important to tell Maya for the dirty propagation, that as soon as this all calculation is done, we want to set this data block as clean. So now this would be a clean data block for a dirty propagation of dependency graph. And we will also define an else condition. So if the plug is not output rotate, that means there is something wrong, because we just have one output block and we are expecting that. So if that happens, return open Maya dot k unknown parameter. So that it would return us the error, because we are not expecting anything else besides the output rotate. Before saving this file and checking it, I would quickly explain in that drawing method that how we have this data handle and data block here. So this is the code which we wrote in Maya. In the first step, we designed a circuitry saying if there is a change in input node, change output. So as soon as Maya knows and there is a change in input, it would look for the compute function. And to compute function, it would supply the plug of output node, plug O1 plus the data block of this node, because all the data is stored in it. So it has handed over a hard disk, and compute function receives this plug and the data block. The first thing is we checked here that plug is correct or not. If we found the right plug, we would extract the information from this container, and the information extracted would point to something which is not readable. It's pointing something inside that data block. Now we want to extract the readable value. So as soon as we ask it to give us a float value, it would give us a number, and based on this number we would perform our calculation, which would give us a result. And this result would go to this pointer, because this is the pointer to our output node, pointer to O1. And after the completion of the compute, this hard drive would be handed back to Maya. Take this data block and perform the calculation or update your viewport or whatever. So this is how this compute function works. So now we can save this code into a Python file and then we can load it. But before doing that, we would just do a quick spell check, because a lot of times there can be a spelling mistake. So I usually prefer either using Eclipse or we can do it in the Notepad++. So I would paste this code and I will set my language as Python. So, and I would quickly go through the code, and we have imported it fine. MID, I will do it small and double check that in the creator function I have used small d. Okay, so because it's highlighted as green, that means it's the same. Then we have declared our class, and these 3M objects would be inside the class, so indentation is fine. Then we have the constructor, and then we have used the constructor. We left 2 underscores after that, so we called the constructor of our mpx node class, and then radius handle, translate handle. It has not been highlighted, so I quickly know that it's a spelling mistake. Inval, in translate, data handle rotate, that's fine. We have created the node creator function, node initialization or node initializer. Then created at mfn numeric attribute, created the attribute, set the properties, adding or attaching the attributes. It's attribute because we are adding one attribute at one time, so it's add attribute, and we are adding in radius, in translate, and in rotate, and attribute effects. It has s in it, but add attribute doesn't have s in the last. And then we are using our plugin initialize, mpx object, register node, node name, node id, that's correct. So we found a couple of mistakes here which we did not observe in Maya script editor, so it's a good idea to recheck your code before you save it and start plugging it in Maya. So now I can go ahead and save this file, and I will save it in plugin folder, and I would call it as wheel node.py. Alright, so now we can go inside Maya. We can load our script editor. So the ways of using a custom node is similar to the ways of using the command plugin. So we are going to use the Python or mel method to load or to register a node. So first I would maya.cmds as cmds. I would execute that, and then I would call a function commands.load plugin, and I would define the path of my Python file, which is stored inside plugin, and I have named it as wheel node.py. Now to create a node, I would call a command create node, and we would use the same name here which we defined in our Python file. So we gave the name wheel node to our node, so we are going to use the same name here, create node. Alright, so result wheel node 1 created. We would go in our hypergraph or hypershade, and here you go. So we have our wheel node here, and now I'm going to quickly create a wheel and a plate. That's our wheel, and I will just quickly draw a plate. them touch, so that it look like wheel and the surface. So now I would go to my hypergraph so that I can connect everything. I would type wheel node 1 so that it selects it. So I have selected my wheel node 1. I want to select this sphere, hypershade, and I will drag and drop, and I would say another. So from the pipe, load left. From the pipe we need the radius, which should be coming from polypipe 1. So we would load polypipe 1 here. Here you go, we found the radius, and we would connect it with the radius of our wheel node. And then we need the translate Z of this plate. So we would reload it here, and we would find translate Z, and we would connect it with our translate of the node. So we have connected both the inputs, and now we want to connect the output. And we would connect the output to the rotation of the wheel. So others rotate and rotate. We would quickly check at what axis we want to rotate. It should be rotate X. Here you go. So we would connect it with the rotate X, and we would try to drag our surface, and yes, it's working. And we can change the radius so that it would change the value, and it would rotate accordingly. So now it's rotating more because the radius is smaller. So this is how we create the dependency graph or the custom nodes, and this is one of the difficult concepts while learning Maya API, and that's why I tried to spend a little bit more time in it, and I tried to include as much as possible. So if you did not get any part of the video, you can go through it again, and I will see you in the next video. Bye.